All right, so there are a lot of different problems we can do involving trig. We're going to try to hit a couple more examples here, but just know that we won't be able to do all of them. So you might see some trig problems at some point that look a little bit different from what we're doing. I'm just trying to give you a good overview of a couple different types of problems you can solve. So the next one I want to do, I want to add in another element of physics to this. So I want to talk a little bit more about speeds. So let's just say that we have an airplane and its angle, a plane's angle of increase, really this is elevation, is about 20 degrees, we'll say, and its speed is 250 feet per second. And I want to know how long until it reaches its cruising altitude. Which for a commercial airline is about, it varies between 30 to 40,000 feet roughly, so we'll just say 35,000 feet. Now this is a made-up problem. I don't know exactly what a plane rises at, and I'm sure it varies depending on the weather, and I doubt it's constant the entire way. I also don't think its speed remains constant the entire way, so this is a contrived example. But we'll just go with this just to kind of give us an illustration. So let's say I have my airplane. I'm just going to use a box to represent the airplane, and it's rising at an angle with the ground of 20 degrees, and it's going up at 250 feet per second this way. Now, what kind of makes this tricky is my height is actually this right here. It's not the 250 feet, that's not corresponding to height. So what I really need to do is figure out what the vertical component of my speed is in this case. Now, if you're in physics, this has probably come up quite a bit. You often break down a speed or a lot of different forces in terms of their horizontal and vertical components or x and y components. So in this case, if you're not a physicist, just know that my diagonal speed is not the same as my vertical speed in this case. So if I go 250 feet this way in 1 second, I need to figure out how many feet I rise in 1 second. And so to do that, to get this vertical component, notice I've created a right triangle here. This is the opposite side, and this is the hypotenuse. And I have an angle right here. So this tells me that sine of 20 degrees is going to give me that vertical component over 250 feet. And we'll just say in 1 second because we can really choose whatever we want. But we'll just say this is my speed per second. So that tells me that the vertical component of my speed is going to be approximately sine of 20 is about 0.34 times 250 feet is about 85.5 feet per second. We could also figure out the horizontal component if we wanted. That would tell us how far it moves in relation to the airport or wherever it started per second. But we don't need that. We just are worried about the height because we want this to reach 35,000 feet. So now I have my speed. Now this turns into not a trig equation, but just a linear equation involving speed. So as a quick reminder, to find out your speed or your velocity, you take distance and divide it by time. In this problem, I'm concerned with time because I say how long until I have my speed is 85.5 feet per second. I have my distance that I want to reach is about 35,000 feet. and then I have my time down here. Solving for time, we end up with 35,000 feet divided by 85.5, which is roughly 409 point, we'll call it 0.4. And the units, since I'm dealing with seconds there, the units here are seconds, 409.4 seconds. This is probably way faster than it would actually happen. We would probably want to convert this to minutes. So let's do 409.4 divided by 60 because there's 60 seconds in a minute. And so I end up with about 6.8, so about, we could just call that 7 minutes. But that's very fast to go. To get up to 35,000 feet in 6 or 7 minutes seems pretty quick to me. Maybe that's normal, but I don't know. So this was a made-up, contrived problem, so who knows. Okay, so this was an example of how you might relate this into a physics problem. We broke this down into components using our trig, and then it turned into a relatively easy linear problem involving speed, distance, and time.